It feels like every single week there's this flood of new AI models, and every single one claims to be the next big thing. So when DeepSeek announced their latest release, a new model for optical character recognition, it's easy to just kind of shrug and think, so what? I mean, on the surface, it just pulls text out of images. But trust me, that is not what this story is about.
And yeah, that's exactly the right question, isn't it? Why should we care about another OCR model? Well, because this technology isn't really about reading invoices or digitizing old handwriting. It's actually about tackling one of the biggest, most frustrating roadblocks in artificial intelligence today.
All right, so first, let's just make sure we're all on the same page here. OCR, or Optical Character Recognition, is simply the tech that lets a computer read text from an image. You snap a picture of a document, and OCR yanks the words out. It's super useful tech, for sure, but it's not exactly the kind of thing that makes huge waves, right?
Well, except this time it is. Because the team at DeepSeek used this pretty simple idea to engineer a solution to a much, much bigger problem. A problem that I guarantee every single one of you who's ever used a chatbot has bumped into.
And that big problem? It's the AI's terrible memory. I mean, you know that feeling, right? You're deep into a long, detailed conversation with a chatbot, and then all of a sudden, it just completely forgets what you were talking about 5 minutes ago. That's not some random bug. It's a core limitation of how these things are built.
In tech terms, this limitation is called the context window. But really, just think of it as the AI's short-term memory. It's the absolute maximum amount of info, which we measure in these little units called tokens, that the model can hold in its head at any one time. Once you go past that window, the older stuff just starts getting pushed out.
And this, right here, this is the heart of the issue. At the start of a chat, the AI has your instructions perfectly. But as you keep talking, adding more and more context, the conversation starts to get fuzzy. It just falls apart. All those crucial details from the beginning, gone. And the quality of the AI's answers just plummets. This memory bottleneck is what's holding back so many AI applications.
So, the million-dollar question is, how do you fix this? How do you give an AI a better memory? Well, DeepSeek's answer is, well, it's totally counterintuitive, but absolutely brilliant. They call it context optical compression. Instead of just trying to cram more text into the AI's memory, they decided to completely change how the text is stored in the first place.
And here it is, the big idea. What if, instead of feeding an AI raw text word by word, you fed it an image of that text? What if you basically took a picture of your entire conversation and asked the AI to just look at the picture instead of trying to remember every single word?
So, did this crazy idea work? Oh yeah, it worked incredibly well. By using this vision-based approach, a document that would normally gobble up 8,000 text tokens can be squeezed into a visual format using only 800 vision tokens. I mean, that's a 10x boost in efficiency. Just wow.
Okay, so let's put that 10x into perspective. What does this actually mean for an AI's memory? You've got models like Gemini already pushing the envelope with a 1 million token context window, which is huge. But if you apply this 10x compression, all of a sudden you're talking about a potential context window of 10 million tokens. Folks, that's not just a little bump. That is a complete game changer.
Okay, so how on earth did they actually pull this off? The process is this really cool pipeline of different AI models all working together in harmony, with each one playing a really specific part to shrink the text down without losing the important stuff. Let's peel back the curtain and see how this thing actually works.
So it's basically this awesome 5-step process. First, an open-source AI from Meta carves up the image of text to figure out what matters. Then, that visual data gets compressed by a factor of 16. After that, a clip model, which is amazing at connecting pictures with words, gets a bird's-eye view of the entire document. Then, another system zooms in on the nitty-gritty details to make sure it's accurate. And finally, a tiny, super-fast decoder rebuilds the text, but only when it's needed. It's just this incredibly smart, modular system where each piece does its job perfectly.
Now, even though DeepSeek might have started this as just an OCR project, some of the biggest brains in AI immediately saw what was really going on here. This isn't just a clever compression trick. It could be a sign that we're about to fundamentally change how we've been building these systems for years.
Take Andrej Karpathy, a total legend from his time at OpenAI and Tesla. He basically said, hey, maybe it's just plain better to feed AI images of text. Why? Because it could let us completely get rid of the tokenizer, a part of the AI that, frankly, he said he never really liked anyway.
So, why is the tokenizer such a big deal? Why would we want to get rid of it? Well, because they're a massive pain. They're the source of a ton of security flaws that lead to jailbreaks. They can be super weird and inefficient, like turning a simple smiley emoji into some bizarre, jumbled mess. And they're a bottleneck that stops AI from being truly end-to-end, meaning it can't just go straight from raw data, like pixels, to an answer. This new vision approach could just sidestep all of that.
And then, jumping into that same conversation, Elon Musk took this idea and just cranked it up to 11. He argued that long-term, pretty much all input for AI is going to be photons, light. And why? Because it's the only thing that really truly scales. He's imagining a future where AI's main sense is vision, not just reading a stream of our text.
Okay, so let's just boil this all down. What's the big shift we're talking about here? The old way was feeding AIs raw text tokens. The new way? Feeding them compressed images of text. The efficiency is 10 times higher, the limitation of a small context window becomes a potentially massive one, and we go from being vulnerable to security flaws to something way more robust. It's a fundamental change in how we talk to these things.
And all of this leaves us with one really fascinating final question. We've spent all these years teaching machines how to read our language, one word at a time. But maybe the real breakthrough comes when we just let them see it instead. So is the future of AI something that's going to be read, or is it going to be seen?